go ahead and check out your solutions. What's that assignment here? Going to do 1 through 13 and then number 16 as well. We did a lot of the simplification on these already. But you check those out. We have a question over
Which made the strong steps let's see. One of them, I was in one of the science school, saying it was like secant squared, and it's going to secant squared.
otherwise. Okay, so like I said, we're not going to actually start on the new section today. If you look at the next section, 6.3, it's on what are called U substitutions or the reverse chain rule, generally just called the U substitutions. This is a pretty important part of integrating because generally when you find integrals, you're not just doing these nice easy ones like you did last night where like for all of the sines and cosines, there's nothing like inside of here other than like, well, this is just a secant theta. It wasn't like secant of 3 theta, right? Same with these. Also, these e to the x's ended up all being, when you simplify them, just e to the x, where it wasn't like e to the 3x squared or something like that. So these were all sort of the easy versions. There was also all of these fractions you could simplify into something easy, right? So there's no fractions you actually have to do it or multiplication. So those are easy derivatives, or sorry, easy integrals. But the next step is going to be to do harder ones, where you can see we're actually like multiplying two products. Here we have the quotient. So it does get harder. Here we've got a sine with something inside of it. Here we have a multiplication of a sine and a cosine. Here we have a function raised to a power. So it does get a little bit more challenging, and to do that, we're going to be doing something called a U substitution, which isn't the easiest thing, especially to teach on your own. So that's why we're going to definitely wait until we have at least one more person here to do that. But you can kind of see what's coming. So I thought today would be a good day to practice these sine and cosines that I struggle a little bit with. So I have a delta math assignment that we're going to do in order to do that. And And again, I'll get into this as well. This up here. So it's this one here. It's called Trig Derivatives and Integrals Practice. The first section is all of them just derivatives with chain rule. So like for example, this first one, try to do these without looking at what the actual derivatives are. So for this one, we're supposed to find dy dx. What's the derivative of tangent?
Secant x tan x.
No, it's secant squared.
Oh yeah.
So dy dx
Oh, that
will
was
be
a secant.
2 and secant squared of 3x. And remember with the chain rule, you gotta then multiply by the derivative on the side, right? So this one would become 6 secant squared of 3x. If you know these, it should go really quick. 10 of them should be like, should be no problem. I know it. So that's what your first section is going to be, just helping you memorize those. Again, try to do it without looking at them. So then for secant, secant is going to be secant x tan x.
Yeah.
So if we were asked to find the derivative of secant of 2x, well, it's going to be secant 2x tan 2x, and then the derivative of the u, it's like our u inside there, which is 2. So it's going to be 2 secant 2x tan 2x. We did these a while ago, but it is important that you know these well. So cotangent, everybody know that one?
Negative cosecant squared.
And there's nothing in there, so that's good. So you get the hang of it. Just gonna help you memorize this a little bit better. I threw in there a few of these. Maybe I'll just change this to 3. 5 could be a bit much. We have to write an equation of a tangent line using the trig function. So given this trig function, write the equation of a tangent line to the function. So let's try this with the first one, do one together. Here's our function. First thing, if we're going to get the equation of a tangent line, would be find the derivative, right? Negative slope. So f prime of x. What's the derivative of cosecant squared? Well, we just did cosecant. But remember, this is the same thing as saying 3 times cosecant of x. 1 squared, right? Same thing. So then in order to do this, we do the chain rule and multiply it. So it becomes 6 times cosecant x to the first power. And then the derivative of cosecant of x. Remember that one? So it's like secant.
Is it secant?
And then you're going to have to plug in that value. Yeah, these might take a little bit of time. So then you're going to have to plug in the pi over 3 into that. And pi over 3. And right up here. Right? So plugging in pi over 3 into that. This coordinate pair is 1/2. You might also need to think about cosecant matches with sine, right? So sine is y, so it's 1 over. It's going to be 1 over the y coordinate right here, 2. And since we have this twice, we could actually just square it. Right? We do have a negative in front. And then for cotangent, that is going to be the x over the y. So 1/2 over 3 over 2. We're going to multiply -6. And then this stuff, we could just flip it and then square it. That would be 4/3. And then square it. So it's 2 on top and 2 on the bottom. And then this here, we flip it. And the 2's would cancel, we would get 1 over radical 3. So then we need to multiply by radical 3 over radical 3. We also reduce this to 8. 8 radical 3. And then we need to, this might be a little bit too challenging. So maybe we'll just try like 2 of them. because then we need to get the y value, and I'm not sure how they want you to type this in. Let's do it then. So m. So here's our x. To get our y, we need to do f of pi over 3. So that's 3 times the cosecant squared of that. We're going to do the cosecant of it, which was 1 over 3 over 2. That ended up being 4/3. So 3 times 4/3, which is 4. So let's try this here. So we do our y minus y1. So y minus 4 equals our m is negative 8 radical 3 over 3 x minus pi over 3. And that's a lot of stuff to get right in one question. Let's see, and I'm not even sure actually if this is the format they want you to get it in. Let's see. All right, I did it. Okay, so maybe you can try like 1 or 2 of those, but that's a lot to get right on a delta math problem. So I'll change that to 2. You could try 2 of those.